Welcome to solverfy.
We're asked to show that the addition of edges at each stage of Sollin's algorithm produces a forest. So to do this, I'll use a proof by contradiction. So suppose that G is a connected weighted graph. And suppose that there is a simple circuit formed in some stage of Sollin's algorithm. And this is, of course, in some stage after we have added the edges. So let E1 through ER be the new edges in this stage. In order of their addition. Recall that in Sollin's algorithm we order the vertices, which also produces a lexicographic ordering of the edges. And then we add the edges incident to every vertex with the least weight. And in the case of tie, we're using the first edge in the ordering. So, and let the trees in the previous stage be T1 through TR. Then we know that the circuit has to be of the form E1 T1 E2 T2 all the way up to ER TR and then back to E1 again. And note that there are the same number of trees as there are edges in the sequence. And this is because this is exactly what Sollin's algorithm requires. For each of these trees, we have to add exactly one edge. So it follows that every tree has picked a different edge. However, suppose that E is the edge with the smallest weight in E1 through ER. So this is the edge with the smallest weight of the new edges added. And of course, if there is a tie, then we're going to pick the edge that occurs first in the lexicographic order on the edges. We had that the two trees that E connected should have both chosen E. This is because, as part of the algorithm, we're supposed to pick the edge with the smallest weight, and therefore, we obtain a contradiction, because as we said before, every tree picked a different edge. And therefore it follows that the addition of edges at each stage of Sollin's algorithm produces a forest.